So hi everyone. So welcome to today's session about Fabric. So my name is Thomas, work in Devo team mCloud here in Norway. So I'm very excited to have James Serra with us today doing the presentation. So James, are you online?
I am here and ready.
Yeah, there you are. Good to have you with us today. Yeah. So
Yep.
whenever you're ready, you can just kick off. Just some around Q&A. Should we just take it in the chat and take it afterwards? Is that fine?
Yeah. In fact, I'll I'll pause a few times during the presentation, and then if you have stuff in the chat, I can go over that. I can see it, or even have you come off mute. Either works for me. But I think we got like an hour and a half, so we'll have plenty of time for questions along the way.
Yeah. So that's good. So yeah. So whenever you're ready, James. So just start the session.
All right, I'm ready.
Yeah.
I don't know if you were recording it or not.
Yes, we are recording, so we're all set.
All right, cool. I still have people bouncing in. Awesome, good. Got a nice group of attendees. So welcome everyone. My name is James Serra. I am a data and solution architect, data and AI solution architect at Microsoft. That's my unofficial title. The official title is technical specialist. It's a new role that Microsoft had, which is really an old role. I won't get into the number of role changes I've had on Microsoft, but I've been there 9 years. I think I've had 10 role changes, or 10 managers, 8 role changes, something like that. But most have been in pre-sales, where I'm at now, and various different industries. The one I'm in right now is called federal civilian. So I work with a lot of US governmental agencies, and that's an interesting number of use cases that come up with that. And I have a long history in IT. It's coming up on 40 years now, and I've done all sorts of IT related roles, and I won't go back to my COBOL days, but I started with SQL Server in 1.0 in 1989, was a DBA for many years, a developer. And then when I came to Microsoft and not about 9 years ago, it's been awesome, and I spent a lot of time educating. In fact, this presentation is something I discuss with customers a lot, and have a quick note on a book that I'm writing exactly on this topic. So I've taken this presentation and expanded it to create this book. The first 7 chapters are available on O'Reilly. If you don't have an O'Reilly subscription, just shoot me an email and I'll send you the first 7 copies if you want more information. I go a lot into concepts, and so we all level set on that before I jump into architectures in there. So I'll cover a lot of the book in this presentation in there, but it's available if you want to know more. So I'm going to talk about a little bit just about data warehouse and data lake, and then I'm going to jump into the architectures: modern data warehouse, data fabric, data lakehouse, and data mesh. And I have to say, these are my opinions. These are not any official stance of Microsoft. I've had some interesting conversations where people thought what I said was what Microsoft thinks. And honestly, there is no one real standard definition of all these architectures that Microsoft has. So internally, we all have our own interpretations, and this one is mine, but it's pretty uniform. And the whole idea of having this presentation and writing the book was to try to help people understand them all and somewhat standardize on the architectures, so at least we can have the same talking points. Jumping into a data warehouse, I'm assuming most people know what a data warehouse is and why you have one. If not, this kind of reviews the reasons why you would have a data warehouse on here. And this applies in the architectures I'll talk about. In another way too is, do we need to copy the data? A data warehouse is taking a copy of the source data and It could be an OLTP application and copying into a data warehouse that is a write once, read many solution in there. And it does that to offload, for example, on here, offload stress in the production system. If I have an end user and I was a DBA for 12 years and ran into this, an end user starts running a query on the production system, and it's not a well-designed query, and all of a sudden the CPU is maxing out, bandwidth is getting maxed out, and you learn the kill command in SQL to kick them out of there. And the reason that's a problem is because the OLTP system is not designed for heavy reporting, and that's where data warehouses first came about. And then you get into all the other reasons why to have a data warehouse in there is a place to integrate many sources of data. So you can have many OLTP solutions, and you need to combine all that data. It could be to keep historical records in a data warehouse in there. When you design it correctly, you can trace the history of data that's changed. So you don't have to do what I see a lot of customers doing is at the end of the month, they save all the reports in some folder system. And if they ever to go back, they look at it because people, maybe they have customers and the customers over time change where they live. And so if they ran the reports now, the sales, for example, reports would be messed up because people move. So in a data warehouse, you can track all that movement. So you don't have to save hard copy reports. You can always go back in time and get accurate results on that. Other things like changing the tables and field names, the source systems, and I've worked with some that have names like T116 and doesn't make any sense. So it's really hard to generate reports off that if you don't understand what these tables are. And so creating the data warehouse, you can rename all the tables and field names to be something more understandable. And it goes on and on about all the reasons for a data warehouse. And these also apply when you think of copying the data. So people misconstrue some of the architectures like data mesh, and they think, oh, you don't need to copy the data. Well, you do, and you do for all the reasons listed here. And so always keep that in mind. That, as we'll get into, is the decision points of how much copies do we need, and try to reduce the number of copies in there. But you're always going to have copies. But you'll see with some of the new approaches like Data Lakehouse, you're reducing the number of copies. And then why have a data lake? And there's a lot of reasons to have a data lake. These are just a few of them. And big thought process or understanding of a data lake is it's schema on read, meaning I could put data in there without doing any upfront work. It's like a glorified file folder, something on your laptop in there. I don't need to do anything to copy data into a folder. Suppose a schema on write in a warehouse is I have to create a database, the table, the fields, the schema, and then put it in there. So a lot of upfront work. The schema on read takes away that work. Now, then this is common with everything I'll talk about. There's always a trade-off. So schema on read means it could be challenging to pull data out because you have to understand the schema at that time. And there's ways of doing that. In fact, I just posted a blog an hour ago that goes into creating a relational serving layer to help with that schema on read. But this allows you to get quick results from a data lake because I can put data in there, and then if I have a good tool, I can then investigate that data very quickly. And also what I can do with a data lake is free up those resources in a relational store data warehouse in there by not having the relational data warehouse do all the transformations of the data. And this was a common problem, still is in a lot of cases. You have a maintenance window at night. If you have just a relational data warehouse, kick everybody off at say 10 p.m. You copy all the data in there, you run all these transformations in ETL, and then you hope everything works, and you copy that data into production, and then you can let people back on. Well, what happens if I want to have a data warehouse 24/7? Or what happens if that compute that I'm using in a relational data warehouse is just not enough, not fast enough for things? So with the data lake, what you can do is take all that data that you need to transform, land it in a data lake. So it's sort of like replacing a staging area that you have in a relational data warehouse, and instead of doing the transformations in there, you do it in a data lake. And so you can have your data warehouse run 24/7. There's no more maintenance window. I mean, maybe there's a few minute maintenance window where you copy the data in there after it's been transformed, but all that heavy compute is done through the data lake in there. And also you can have more compute because the data lake is just storage. You can attach all sorts of computes. You can fire up a Databricks cluster of 100 VMs if you want to clean the data on there. And it's usually a lot cheaper than what the relational data warehouse compute is on there. So all that gets offloaded, done in the data lake, and then copied to your data warehouse in there. And so that's just giving you a handful of the reasons in there. My book and blogs go much more reasons for having a data lake in there, but just wanted to give you the gist of understanding that. And thanks for posting my blog, and thanks for that phone, the red phone back there. I usually tell customers that's my direct line to Satya. So if we have any tough questions, I can call on him. But he said only once a month I can call him. So the combination of a data lake and a data warehouse, which I get into the next architecture, if you have both of those concepts, you can think at a high level, this is what you can do with what you want to do with each. The data lake will be your more of a staging and prep area, and your data warehouse becomes, instead of the data warehouse doing everything, it becomes a serving, security, and compliance layer. And the data lake is more for the power users or data scientists who are okay with going through data in a file format structure, where the data warehouse, because you do that upfront work with the metadata and having all the information about the data tied to the data, that it could be a lot easier. So somebody does the upfront work to make it easier for the end user to go and query that data. Now the tools are changing to make it easier to do stuff just off in a data lake, and we'll talk about that. But traditionally, data warehouse has been that presentation aspect, used for presentation and report writing for the end users in there. Also, the data warehouse has more security on it. Things like roll-up security, column security don't exist in the data lake. It's a file folder format on there. The data warehouse, which has been around forever, has that capability. So a lot of times customers will use a data warehouse for the serving layer because of that security on there. As an example, if I have a file in a data lake and it's got millions of rows and they're broken out by, say each row has department number, and an end user can only see certain departments. You have to limit what they can see. Well, if I'm in a data lake, the security is on the file itself. So it's an all or nothing. So that's not going to work. So what you have to do in a data lake is you would have to break up that file into, say, a bunch of files by each with one department in there, and then copy it to particular folders, and then give people access to those folders so they can only see the data that's appropriate to them. So it's a lot of work. Or I can just copy that giant file into a data warehouse and use roll-up security from the data warehouse or a tool like Power BI on there. So there's those trade-offs to think about. So this is getting not as difficult with some of the new technology, but it's still a problem when you come with the roll-up security in there. So anyways, that's the way to think about it. Difference between the data lake and the data warehouse when you have both in an environment or architecture like the modern data warehouse. And I often whiteboard this with customers, which is why I kept it in this format in here. I usually go through the first 5 stages with the customer and then talk about what happens at each of these stages. And they wind up with a very high level overview of what their solution architecture would look like if we were doing the modern data warehouse. And later I'll then apply the products that you may want to use, and which I highlight in green here. But the architecture, it could apply to any technology. And my book is vendor agnostic. So I talk about these technologies, and then I can easily swap out Amazon here or Google or other products like Informatica could all be put in here. So the idea is you're going to ingest this data, and in step 2 is it's going to land in a data lake. And within the data lake, you're going to have many layers. And this is what I covered in my latest blog too, is you have traditionally raw, clean presentation. If you're familiar with Databricks medallion architecture, it's gold, silver, bronze that they have in there. But either way, the concepts are the same. And once the data lands in there, and this gets a lot through data lake design, you got to figure out not only the layers, but the folder structures that you're going to have in there. So I'll spend sometimes a few hours with customers on data lake design, because the folder structure is going to affect security, as I touched on, performance, just organizational complexity, and each layer is going to have different folder structures. So you really got to think through that so you can support whatever data is coming across and not have to go like, oh, well, we didn't think about this data. We now have to reorganize things. And when it lands in step 2, which is a schema on read, if I have a data scientist person who has a hat on in my drawing, that person could be skilled enough to say, just land the data in the data lake. I can make sense of it there. I have the technical skills to do that, which used to be very challenging. It's getting easier now, but still could be challenging because of that separation of the metadata with the data. The problem with the files in a data lake is the metadata could be within the file. They could be separate in another file, or it could not even exist. So that's where it gets challenging for people to wade through the data and understand it. But once the data lands in there in the raw format, this is where most data, if not all of it, needs to be cleaned. So step 3 comes into play, where I attach compute to that layer. It could be data factory data flows, now Fabric data flows in there. It could be Databricks. It could be some serverless component of a product like Synapse in there that's going to pull that data in there. And it could be a Spark notebook. And then I'm going to clean it, and I'm going to write it back out to the data lake in that clean layer. That still may not be enough for end users to consume it at that point, because maybe you need to take that data and you need to join it together with other data. Maybe I need to aggregate it. Maybe I need to create a star schema. All these things that I need to do to it, and then put it into the presentation layer. And at that point, that's where end users can start consuming it. I also may have a sandbox layer for that data scientist who wants to play around with the data. You copy it to them, and it doesn't affect those other layers in there. Now, with the modern data warehouse, usually the presentation layer was not enough. So, and this is where things are changing a lot, but step 4 was to model data, meaning I need to put it in a relational solution like a Synapse or a SQL database, because it was too complex for end users to grab it from the presentation layer. And so you would copy it to not all the data, but maybe a large portion would go into some relational storage. Maybe you copy it in third normal form. Maybe then you convert it to a star schema and land it into that relational storage in there. And then step 5 comes into play, where an end user using a tool like Power BI can quickly and easily take that data and create reports and dashboards from it. Self-service BI. You've made people, you meaning someone in IT, have made it really easy by copying the data and having it in a way that an end user can not have to know much about technology, if anything. If you create, say, a star schema, they don't even have to know how to join tables. They just go and click and drag, and it's really easy for them to create reports. So IT does the work. So the end users are not having to go to IT and say, can you create this report for me, please? I've been through that. It wasn't a lot of fun. And therefore, IT is not the bottleneck anymore. So that's the idea. And so you look at this, and yeah, there's a lot of copies of the data, meaning extra costs, meaning more ETL, more complexity. But the benefit of that is the data is in a form that's really easy to use. All right, so let me pause there. I don't see any questions in the chat yet. All right, so Dan's got one. What method would you use to extract data via web API, and where would you land that data? For instance, would you use ADF in the stage and data lake, or use Power Query to go straight to Power BI? Yeah, thanks for that question, Dan. This is where step 1, ingest. I can spend a long time with customers talking about that. For example, I would say if you're doing stuff on-prem, you may have servers that are sitting right next to each other, and you take your source systems and you copy into a data warehouse. Well, you don't care about the bandwidth because they're interconnected. If you start doing things in the cloud, now you got to think through the data that could be still on-prem has got to go up and copy into the cloud. So now I have to be concerned about that bandwidth that goes there. What is my connection speed from my location to the Azure? And if I'm transferring a lot of data, that could be a big problem. So how do I solve that problem? If I have to transfer, say, 100 terabytes a day in there, well, I can get a bigger pipeline. Microsoft has things called ExpressRoute that gives you that extra bandwidth to the Azure. As well, or in addition to that, I may want to break up that file that's 100 terabytes. Instead of doing it every night, maybe I do it pieces of that once an hour. And that could be a solution, as well as doing incremental or updates in there. So instead of doing a flush and fill, or maybe I'm copying all the data, I just see what's changed since the last time I ran that ETL, and I just pull that data instead. So there's all these creative ways to reduce that ingestion piece, and as well as cleaning the data. Maybe I don't want to wait till night to clean all the data because it'll take too long. So I ingest some of the data every hour and then clean it at that point. Now, that ingest could also be a web API, and regardless of what connection is you're going to land in that raw layer. Now, companies have different layers sometimes. Sometimes they'll have a landing zone before it gets to the raw layer. Sometimes they'll have a conform layer because maybe the data lands somewhere is in CSV format, some JSON, some Parquet. I want to create a conform layer where I take all that data and make it into one format, usually Parquet. So there's a lot of flexibility. Most customers have all different solutions on here. And so you'll have to think through, because every use case is different with customers. And I can draw this out, but every customer is going to have different exceptions to this or different variations of this. So hopefully that explains it. And then usually if you get into products, like you talk about Data Factory, I can use Data Factory, a copy pipeline to go from the source to the destination. And in that case, and in most cases, you want to do ELT. I'm going to load it as is in the raw. And this helps for many reasons. For example, reducing the stress on the system because you're not copying data and cleaning it on the fly, which takes longer. So I just quickly land the data in the raw. And then I may use Data Factory copy pipeline for that. Once it's landed in the raw, then I may say, well, I'm going to use Data Factory Power Query, and I'm going to then take that raw data, clean it, and then land it back into the data lake in the clean layer using Power Query or mapping data flows, or maybe a script, Python script in Spark. So there's a lot of different options you have in there. Usually it's a combination of things. Rarely will the company just say, we're going to do everything in say data flows or Power Query. I usually recommend do that until you can't. And when you run across a situation, maybe that particular situation, you'll do it in something like Spark. But don't feel like you have to do everything in one solution. All right, so hopefully that helped. All right, so yeah, continue to feel free to drop in questions in the chat window. Okay, so that's one of 4 architectures. The second is Data Fabric. This is generally easy to discuss. This is my view, and when I talk about in the book, I view Data Fabric as sort of an evolution of the modern data warehouse. So if we look back at the modern data warehouse, notice I don't have things like dealing with streaming data. This is all really batch. And I'm not dealing with things like master data management or API calls to pull the data out. That's where we get in a Data Fabric. Think of it as a fabric. It's going out and weaving its way through data and be able to adjust data no matter what the size, the speed, or the type. Well, to do that, you're going to have to add additional functionality to a modern data warehouse. Additional things about data access and policies. You may have a metadata catalog, something like Purview, track the lineage in there. You may have master data management, a tool like Prophecy in there. You may have a layer of virtualization in there. You may be ingesting real-time data. You may want to create APIs to access the data instead of using connection strings in there. You may even go to as far as creating building blocks. So in my solution, I could have, say, a piece where I'm ingesting data, and somebody in my company may say, well, I don't really need the Data Fabric, but you created this cool ingestion piece. Can I use that? Well, if you design it right as a product or as a service, you can then allow other people to use that code. And so I've seen customers do that all along the way within the data fabric, is make pieces of their solution usable by other organizations within their company, or even sell it as a product in there. So that's really a data fabric. It's just adding a lot more to it. And so with customers, I will often talk to them, ask them a bunch of questions. I know I'm plugging my book a lot, but I usually talk about architect design session. I list all the questions I will ask people, and that will then I'll start adjusting this whiteboard. And oh, you have real-time streaming needed. You need to pull data from, say, Twitter, or no, wait, it's called X now, or from IoT devices. Well, that adds additional complexity. Let's look at that and talk about products for that. So in the end, I see people not using the term modern data warehouse. They use data fabric for everything on there, which is fine. There's a little confusion with Gartner's view of a data fabric, which is more of a intelligent data fabric, is what I call it, and that the data fabric is able to automatically find other sources of data and automatically clean them. I've never seen anybody build a solution that does that. It's a lot of, in my opinion, pie in the sky stuff. Hopefully we'll get there one day, but for now it just doesn't exist. So I'm doing data fabric, not to the level that Gartner and some other people go to, where they add this intelligent piece to it. Maybe with ChatGPT we're getting closer to that, but right now there's really nothing that is that sophisticated. But in the end, it's the same. You just want to ingest all sorts of data, no matter what that size, speed, or type. All right. Yeah, and I will share this deck out afterwards. I have to email it because I can't attach it because you're an external person in there, but I'll send it out. All right. So jumping, does nobody got their hand up? You can also raise your hand too if you're able to do it in there. So, okay, let's continue with architecture number 3. This is a data lakehouse, and indulge me for a couple of minutes of history of how we got here, so it makes it understanding things a little better. Back in the late 80s, and I was starting my career in 1985, there was data warehouse concept came about around that time, and there were products in the late 80s like Teradata that the idea was take a relational data warehouse in there and use newer technology. You may have heard massive parallel processing technology, which is still around and actually still used in Fabric. And everything was done in this enterprise data warehouse in there. It did your reporting, your ETL, your SQL engine was all in there. And this worked great, especially on big data at the time, which was like a terabyte. Times have changed. And everything was on-prem, everything was in a relational database. Then the cloud came around, and of course that meant consuming a lot more data. And this concept in the late 2000s came around called the data lake. And it was all, back then it was a lot of it was on-prem still. And it was the idea that I can just land all the data in the data lake now. And it was this magical land of unicorns and rainbows where it was easy to pull the data out and data was nice and clean, and that failed miserably. And I have a lot of customers that went down that path because they said, oh, we're going to get rid of our relational databases. We don't need them anymore. My relational data warehouse is in there. And when they found how difficult it was to use a data lake with a technology, imagine going to end user and say, hey, your data's sitting there, go use Hive SQL and MapReduce and have fun, and it just failed. And so the data lake didn't go away, it just morphed into something different. So instead of using a data lake for everything, it became, let's use a data lake for pieces of what we used to do with a data warehouse. And as I just explained, that big piece was transforming the data. So we came out with the modern data warehouse in the mid 2000s. Some people called it cloud native platform because most of this was now done in the cloud. And it was a combination of what I just talked about, the data lake and a modern data warehouse and a relational data warehouse. Okay, so then in around 2020, Databricks came out with what they called a data lakehouse. We'll take a data lake and a data warehouse, and we'll combine the terms to come out with Data Lakehouse, which says we could do everything with a data lake and not use a relational data warehouse anymore. And you're going to go, wait a minute, you just said that didn't work. What's changed? Well, what changed in 2020 was Databricks came out with Delta Lake. And that was the idea, was the technology that in some use cases, now probably many use cases, you can get away without using a relational storage. Well, what is Delta Lake? Delta Lake is a software layer on top of a data lake. It's not its own storage. And the idea is, let's take a data lake and add relational database warehouse-like features on top of that. And that will allow us to not have to use a relational storage. That, and I'll get to the trade-offs with that, but that worked and continues to work well as technology advances to allow most use cases to not have to have relational storage. The Delta Lake added features like asset transactions, which, and I'll point out, works on one table, not a bunch of tables, but enough that it made for more consistency with a data lake. It supports time travel. You can version data as it goes in there. So you can run a query and say, tell me this data as of 3 weeks ago. That's great for rollbacks, for auditing, as a couple of examples in there. It was a one technology for using streaming and batch instead of having separate products for each. You can use Delta Lake, and especially if you're using Databricks, for everything. It had things like schema enforcement in there. So without that, if I have a data lake and I'm using ETL or ELT and I'm pulling, well, let's use ETL, I'm pulling data out of there and I'm using data factory, data flows, or Spark notebooks, and I expect all the files in there to have the same schema. Well, somebody dumps a file in there that's completely wrong, and the ETL is going to blow up on there. Well, Delta Lake has an option there where you can say only data can land in there if it follows a particular schema. Otherwise, it kicks it out. So that's a big thing that made Delta Lake easier to use and make data lakes easier to use and more relational data warehouse like. And then in particular, and this was the big one, it's Delta Lake supports delete, update, and merge commands. You can go into like a Spark notebook and use those commands against a file, which you can't not do with Data Lake. It doesn't understand those commands in there. And it also is pretty performant in the way it does that. Otherwise, in a data lake, if you want to update data, you have to pull the whole file into memory. And if you're using Spark, you use like a data frame, and then you update it all and write it back out in there. Imagine taking a huge file that could take forever on there. So that was a big thing that made, again, you able to use a data lake sort of like a relational data warehouse in there. And then there's other performance improvements in there and a small file problem. So a lot of things Delta Lake did to say, well, actually, I can get away with not having a relational storage or relational data warehouse, which is using relational storage. And Delta Lake is also pretty easy to use. On the right-hand side, you'll see here, it's instead of storing something and say, specified Parquet format, you just say, I want to use Delta format. If I'm using, say, a Spark notebook, and that was it. Behind the scenes, if you use Delta, it does store in a Parquet format, but it breaks up the file and has a Delta log and other things in there. So the products need to understand Delta Lake in order to use it. And that's where we've come a long way. And most products, especially in the Microsoft world, support Delta Lake. And so the use cases become for a data lakehouse, which is in the end not using any relational storage, is the benefits, it solves 4 problems. One is, if I have a data lake and a data warehouse, I have to keep them consistent, and that could be a challenge. What if my ETL breaks in there? So that goes away because it's just one copy of the data. It's also avoids the problem of the data in the warehouse being older because it's got a copy from the data lake. Maybe it does that once an hour, so it's an hour behind. Most machine learning tools go well against a file folder format and not so well against relational storage, relational model in there. So Data Lake is Lakehouse, doing stuff in the data lake is a lot easier for a data scientist to do it in there as opposed to a relational storage in there. And then storage has become pretty cheap, but you only have one copy of the data. So you get that benefit of that. So this does open a can of worms, which I'll talk about now, because there are trade-offs. I see one question in there is, Data Fabric and Microsoft Fabric, are they the same? Oh, yeah. Interesting choice of product naming that Microsoft has. They're not the same. Data Fabric is think of it as a concept. It's an architecture. So Microsoft Fabric is the name of the product that, is trying to help you build a data fabric, but it could be used for other things. I can use Microsoft Fabric to build what I would consider a data lakehouse, and that's what most people use it for, or what I consider a data mesh in there. So not a fan of the name in a way, but I do like it in that it is a flexible tool that can handle data around the size, of speed, or type, but it's not designed just to solve for the data fabric architecture. It can be used for any architectures. And then another question, Fabric versus Databricks, Delta Lakehouse, when do you use and the differences? So Fabric, which is another presentation of mine, uses Delta format for everything. And Databricks created Delta format. And this means I can use both products on the same data. I can go in Fabric and I can save data into Fabric has what's called a one lake, and all the data I use in Fabric stores in Delta format. So then Databricks can go and create a shortcut to that and use it because it knows Delta format. On the other end, you can do stuff in Databricks and store it into some data lake using, say, Data Lake Storage N2 in Azure. And then in Fabric, I can have a shortcut to that and use it because Fabric understands Delta Lake. So it's not choosing one or the other when it comes to certain things, and storage is one of them. You can intermix both of them. So hopefully that helps. All right. Jumping into the can of worms is, okay, if I skip the relational data warehouse, what are the trade-offs? Well, one of them is speed. If I have data in a relational storage and there's a SQL engine on top of that, I'm going to have queries that are going to run faster than they would against a data lake or a Delta lake. Many reasons for that. Biggest being relational data warehouse has been around forever, and they have many optimization techniques. Massive parallel processing is one, if you're familiar with that. It's got things that are not in Delta Lake, like cluster clumps or indexes, cache and query plans, materialized views, even joining tables. All that could be done in a relational database where you don't have that in a Delta Lake. Now, there are some exceptions to that. You can say you have statistics, but it's very limited compared to what you get from a relational database in there. So if speed is an issue, then that could be something you got to think through of, can I get away with that? And should I go with it? Because you're deciding, do I create that relational storage, a modern data warehouse, or do I not use that and just do everything at Data Lakehouse? Other things you're not going to have, as I mentioned, roll-up security, common security, dynamic data masking, they don't exist in Delta Lake. No way around that. The complexity of dealing with a file-based world could be challenging for end users. You got to think through that. Concurrency, it could be very challenging if you have a lot of people accessing the same file in a Delta Lake, and that you may not have that problem in a SQL data warehouse in there. There's features that are missing, like reference integrity, that doesn't exist in a Delta Lake. There's no way to put that in there. You have to do it in code, as an example, in there. So there's things to think through that. Now, not each one of these may not be enough to say I'm not going to use a data lakehouse in there, but in combination they may be. There's the other thing, if you're using Databricks, you're going to have to use Spark SQL to access data in the data lakehouse in there. Well, the Spark SQL and T-SQL are pretty similar, but I go to customers and they have hundreds of people that are familiar with T-SQL. You have to retrain them, so that's a big consideration. That could be deciding which way to go in architecture-wise. Products have to support Delta Lake if you go that route. Most do, but some, not all of them do. And then people are just using that relational database where you have this forced metadata layer on top of the data. So it makes it a lot easier to find the data if somebody's done the work, as I talked about before. Now, where this is changing, this is a big change, is there products have come out now that overcome a lot of these issues. Not all of them, but a lot of them. Synapse and now Fabric have features that help with something like T-SQL. I can go into either product and I can create a view in T-SQL on top of a file sitting in Delta Lake. And that means I can then have end users use that view, whether they're doing ad hoc queries or using Power BI, and not even realize they're using a file. They will think they're using a relational storage, relational engine on here, but they're not. And they could then write T-SQL queries against that view. So you're solving the problem of them having to learn Spark SQL. So those products now allow you to use T-SQL, and especially Fabric make it even easier to do all your T-SQL against data sitting in Delta Lake. So that you can say that got rid of that problem in there. Things like speed. Well, in combination of using Synapse or Fabric, I can use Power BI and I can pull the data, import it into Power BI, and that solves my problem with speed. I'm now getting millisecond response time because it's in memory. Fabric's got additional features for that direct lake, and won't go into that, but a lot of technology now is coming in to overcome that problem with the speed. And then you'll eventually see products like Fabric have roll-up security. But in the meantime, I can pull that data into Power BI, and Power BI's got roll-up security, so I can mark that off the list in there. So at one time a few years ago, before all this technology came around, I was like, I think we're always going to have relational databases. But then technology came along where I started saying, maybe we can get away with having a data lakehouse, not have that relational storage and SQL engine in there. And copying that data, it really comes down to copying data into relational storage on that. And so Fabric has gone a long way into essentially getting rid of the idea of having relational storage in there. Fabric is all about a data lakehouse. There is no, if you're familiar with Synapse, there is no relational storage or dedicated pool. That's gone. And so I think in a few years, I would say 90% of the solutions will be in a data lakehouse. There will be no relational storage. Something I never thought I would say a few years ago, but it's become a reality. So let me pause there if you have any questions. I see one, Alberto has Delta files from Fabric are 100% compatible with Databricks. Yes. So if I do anything in Fabric, it stores it in Delta format. There are some optimizations you can do within Delta Lake when you're using Fabric, a thing called vorder and write optimize. If you do those performance features will work within Fabric. They won't work within Databricks. However, you can still use those files within Databricks. They just won't use that performance enhancement in there. But full compatibility between Databricks and Fabric with Delta. Now, on the other end, if Databricks comes out with some new performance enhancement that's only specific to Databricks, the same thing. The file will still work in Fabric. You just may not get that performance boost in there. Now, it's not to say that Databricks will come out with some new feature in Delta Lake, but that would prevent that. But that hasn't happened, and because it's open source, it's unlikely to happen. So I'm confident Databricks or Microsoft won't do anything that will make those files incompatible. Question 2 for ADF. Read Delta files need a Databricks cluster, if I don't confuse. It's the same for Fabric Data Factory. So within Data Factory, you have to have, I think you're talking about a Databricks cluster. So behind the scenes, Data Factory is using a Spark cluster in there. It used to be Databricks, now it's Microsoft Spark. So it's going to use compute. And within Fabric, within Synapse, if you're using integration runtime and something like data flows or Power Query in there, you specify all the compute you're using. You don't need to do that in Fabric. Fabric has a universal bucket of compute, and there's no more having to specify it. So there's a lot of benefits about Fabric. One of them is not having to specify the compute. Will Delta Lakehouse be preferred to Cosmos DB? I would say they're two different things. Cosmos DB is for OLTP solutions, high transactional solutions. It's a NoSQL solution. Generally, Cosmos DB comes into play if I built a solution in SQL Server, SQL database, it may handle 10,000, 100,000 transactions per second. If I build some cool app and people want to use it, and I need to support 1 million transactions per second, well, it's very unlikely you're going to get that performance in SQL database or server. That's where Cosmos DB comes into play as one reason to use Cosmos DB. But that's all OLTP, online transactional processing. You're doing a lot of individual updates and deletes and deletes in there. Very different from Delta Lakehouse, where it's, although you can do individual ones of those, it's still focused on, some people call it OLAP, just data warehousing, write once, read many. You don't want to use Delta Lakes, for example, for some order entry system. It's still for data warehousing in there. So a good question, because I don't want to confuse that Delta Lake is something that will replace, say, SQL Server or SQL database. No, it's for data warehousing. All right, application connection and dashboards. I'm not sure what you mean by that. If you're trying to connect a Delta Lake, you just have to have a Delta Lake connection, and like Power BI has that, most products have that. So if that's what you're getting at, an application needs to be able to read Delta Lake. So whatever product you're using for that, it's got to have that connector, and most do. And another one, when you say we can access files as tables, do you mean about Polybase and Parquet files, external tables? Sort of. It's Polybase is you can say used behind the scenes in something like Fabric, and used in Synapse, and used. I get what I think you get at external tables. We've just made it so in essence they're using the concept of external tables. Microsoft just made it easier. Instead of going through all that code to connect to an external table in Fabric, you don't even need to do that anymore. It just automatically connects to it. It's pretty impressive with Fabric. Always happy to do a follow-on demo of Fabric if you haven't seen it already in there. So behind the scenes, you could say it's doing that external table code, but it's abstracted from you. They made it really easy. All right. Thanks. Good questions. I'm going to jump to our fourth, data mesh. Everything I talked about is centralizing the data. It's taking from all these sources. Sources could be in parts of your organizations. You can call them domains. And it's pulling it all into a central location owned by IT. And then IT does all the work to create the analytical data and build the solutions that end users are now going to consume. Data mesh is about decentralization. It's about giving all those organizations, those domains, keeping ownership with them. They create the analytical data, and it helps with scaling. So it's decentralizing not everything, but a number of things that I'll get into now. It's important to note data mesh is a concept. If you read John Mick's book on this, and she invented the term data mesh and did a lot of great work and promoting it, you'll find that there's very little technology discussions on there. And when I talk to customers about building a data mesh, it's all about organizational culture shift. That's what a data mesh is about. I'll tie in how technology fits in, but in the end, you can say you can use a data lakehouse or a data fabric to build a data mesh, but data mesh on itself, it's a lot about cultural change within the company. A data mesh is not a magical wand you can buy on eBay. It's been promoted and hyped. There's no data mesh in a box. And if you look at the Gartner hype cycle, you can see data mesh is going up in that big hype. And then it'll be that trough of disillusionment, they call it, where people are going to go like, oh, it wasn't everything I thought it meant to be. Interestingly enough, Gartner says that, including in the X here on data mesh, it's going to be obsolete in like 5 years, which I don't agree with. I think, and we'll get into this, but I think parts of data mesh will always live on, the ideas, but a pure data mesh, if that's what they're going for, yeah, nobody's going to create a pure data mesh, and we'll get into. The data mesh at a high level is made up of 4 principles that Jomic touted in her book and her blogs. And I try to simplify this. And I had to read her blog like 100 times to try to get it and understand it and explain it in a way that's easy for people to understand. The one is domain ownership. It's the idea that those domains, so you can have an organization and you have HR and finance, call those domains, or manufacturing, sales, supply. They know the data best. They should be the ones that own it and clean it and do things to it. So let's have them own the data as opposed to copying that data into a central location and IT becomes the ownership. Ownership stays with the domains. Because they are retaining ownership, they are also going to treat data as a product, meaning your domains are now going to take that operational data and convert it to analytical data, and they're going to use their own infrastructure and compute and build it out themselves. But to do that, they have to be useful. They have to make it available to everybody else outside of their domain. So they need to create maybe APIs that allow people to pull the metadata and the data from their domain. But each domain is going to have their own domain teams. So instead of passing that operational data to IT, they keep the operational data and then they create the analytical data and then make it available to everybody else. Now, that's a lot of work. So how can we make it easier for each domain? You could have, some customers have hundreds of domains. How are we going to make it easier for them to go and now they have to build all these solutions? Well, that's where the other 2 principles come into play. Self-service data infrastructure as a platform means a centralization, this is where it happens. A central IT team may build a solution. Maybe there's scripts that they can give to a domain to click a button and say, okay, answer these questions, and this script is going to build your infrastructure, and it's going to include all the things you need to get started to build your solution, your analytical solution, which could be firing up Databricks for each domain or firing up Microsoft Fabric for each domain on there. You're shortcutting the process by building the compute and pipelines and storage and security for each of those domains. There's no product out that exists that does all of this yet. There are products that do pieces of this, but all the customers I've seen, they're building their own infrastructure as a platform. So there's a lot of work that's going to be done beforehand to even get domains to get started. Added on to that is federated computational governance, which is, hey, look, we can't have all these domains going and building their own thing and choosing their own security. We got to standardize on that. We got to have some global rules. We got to tell them how the security should be, how they should follow regulations if we're in, say, a regulated industry, how they should do modeling and data quality. We can't have everybody doing things differently. We can't have one domain deciding we're going to abbreviate states, US states, another one using the full name. We got to have these playbooks to follow, and that's where 4 is usually done by a centralized team. Now, maybe that centralized team is a combination of the domain teams, but they got to get together as a group centrally and come up with this playbook that they then hand to each of the domains. So they're following some of the same standards, or otherwise you'll have a mess on your hands. I mean, can you imagine one group domain saying you can use API code to get our data, another one saying you can use connection strings, another one saying you're going to use some web URL and that. It's just going to cause a nightmare, especially if you join all that data together. So what you wind up having is a combination of yes, 1 and 2 of the principles are decentralized, but then 3 or 4 are actually centralized. And that's where people get confused on there. Not everything is decentralized. But again, it's a concept. So none of this, I'm talking about technology. So the use cases for data mesh is it solves 4 problems. And I've been in meetings where you almost got into fistfights of who owns the data, who's responsible for cleaning it. That goes away. It's now this data source team in there, not the infrastructure, not central IT on there. The quality is improved, at least in theory, because the domain teams know the data better than the central IT team. So they're the ones now that own it and are going to clean it, and they're going to do a better job of cleaning it. And then 2 big things for data mesh is scaling. Think of organizational scaling. If I have all this data and I need to ingest it, and I'm IT, I'm going to be bottlenecked. I'm not going to be able to keep up with all these requests to add more data to the data lake or the warehouse on there. And that's a big problem with a lot of companies in there. You can, hire more people in your central IT, but that's only going to go so far. Not only that, there's the technical scaling. They may have created a solution, but it can't handle data up to a certain point. I don't have enough compute or storage on there. So these are the 2 things that data mesh overcomes. Organizational scaling wise, if I have a new domain, each domain now creates analytical data. They're going to create their own teams. So more domains just means more hiring, more domain teams on there. So you solve that organizational scaling problem. Also, the technical scaling. Each domain, as I said, creates their own infrastructure. The more domains, the more infrastructure. Great, I solved the technical scaling. Obviously, there are problems with that I'll get into, but the idea at a high level is awesome. I overcome all that scaling issue with a centralized solution. Now, so let me pause there. We've got some questions. Now, Sophia said, data mesh is like DevOps, not technology, but a concept and a culture. There's an overlap between the 2. So you'll see a lot, and Zamek talked about DevOps, and it's like DevOps in you're taking code and you're splitting it all out on that. Now, I don't agree with that totally, because data is a lot different than code. And so she talks a lot about treating data as a product, which I'm going to talk about next. And then she's even created a new company that's treating data as a product. She calls it a quantum. And the idea is I can have a piece of data, and within that piece of data is also all the rules for cleaning the data and mastering the data and lineage and all this other stuff, which I think is extremely challenging. I've been in this a long time. My opinion, I don't see how that's going to work, but okay. Hopefully it does work in some capacity in there, but it's because there's the mindset of just treat it like code, but data is just so different. And I get into this in my book, so we'll leave it at that. But there is at least at a high level, think of it as if I'm like code, if I'm separating it out into pieces everywhere, the same thing with data with the domains, I'm separating out into pieces everywhere. Okay, another question. The most challenging principle is number 4. We can implement and handle the first 3, but number 4 is complex, since many partners should take part there. Yeah, and this gets into, well, I'll just start here, is you have these 4 principles. You can say if you follow all those 4 principles, you have a full data mesh. Now, within each of those principles, you also have to fulfill it completely to, you can say, her thought process on what does it mean to have data as a product? And as I said, she has this quantum idea. So if you treat it as a product, but you don't go full quantum, I'll say, you're not satisfying the full definition of that principle. And so this gets into a lot of gray areas. If I build a solution and I follow 3 of those principles, can I call it data mesh? If I follow 2 of the principles, can I call it data mesh? I talk about this again in my book, A Minimal Viable Mesh. I don't think there's a great answer to that. I've seen customers that use virtualization layer on top of their solution that they built, and they connect all the data, and they say, oh, look, it's a data mesh. Well, they're not following any of the principles. They're not even following domain ownership. They're still having IT own all the data. So it's you can say it's a federated solution, but it's not federated data solution, but not a data mesh in there. So this is where that big gray area is. So I haven't seen anybody create a data mesh. You probably never will. And if I follow, say, the first 2 principles, and I'm doing most of not all of them, call it data mesh, fine on there. But this is where this big gray area is. And what winds up happening is customers will take some of those principles and they'll use them like domain ownership, but they will build something that is really a data lakehouse with just a lot of, say, workspaces in there on that. And you can call it data mesh, fine, but it's really not. So there's no great answer to, fill out this question and answer, and I'll tell you if you have a data mesh or not. All right, another one, Joanne. You see knowledge graph, semantic tech will play an important role in the data fabric. I touched on that before, and that's where you get into the intelligent data fabric that Gartner has. And a lot of people talk about knowledge graphs, and the idea is you can use that to relate data and how it all, so you can lay out how all data relates, and it makes it easier to understand relationships. I honestly haven't seen a company do that yet. So some of the technology is there, and it's great. And I do see that semantic graph, semantic layer, those kind of things get into. We'll get into there in the future, I think. But I just think that's a level of complexity that I haven't seen any company go to yet. So the idea is great, but maybe if you have this knowledge graphs, it makes it easy to create reports because it understands all the relationships. But I honestly haven't played with any of those tools yet. Just no companies have gone that far yet. So it'll be interesting to see. I imagine I'm starting to see people get into that a little bit, and I just need to play with the tools to see how well that actually works. Leon says data mesh is interesting. It turns out that is what we are doing in exactly this way. We just didn't know the word for it. So that's the interesting thing. Like Pete Hine is an author, and he created this book, Data Management at Scale. And his book was all about data mesh before it was called data mesh, before Jamit came out with her blogs. And so he had done the second edition of the book. It's an awesome book, and he now used the term data mesh in there. And to your point, Leon, I've seen a lot of customers go, oh, I was building a data mesh and didn't even know it. So what she created was not new. She just created a nice term for it and organized it really well. And then even if you don't use a data mesh, it's good to go through and understand the data mesh because you take away some of those principles. And whether you build is considered a data mesh or not, hey, whatever works for you. All these architectures in the end, most customers are going to take bits and pieces of each and build their own thing on that. I wish there was a playbook I could just give you and say, answer these questions and you'll know what architecture to build, but everybody's different. So let me, before I get to the next question, let me do a little data about data domain. So the idea is you have to build out this cultural change, and you have to reorganize your whole company. And this is where most customers don't use data mesh, into data domains. Now, maybe you break them out by some common business purpose. It's not enough to just say HR and finance and there. Usually they have to be broken up into more discrete, and because within each domain, then you have to think of products. Each domain has a number of products. For example, you could have patient data, and as a domain within there, you could have many products. One could be data analytics, one could be patient satisfaction in there. So this whole thing called DDD, domain-driven design, customers will spend months and months trying to think conceptually how it's all going to be laid out, and then you have to go in and actually tell people, well, you're moving to another group because we're breaking it up by domains. So that stops a lot of customers in their tracks. They can't handle that. But that's a major part of really the first part that has to be done. Now customers will do it incrementally, that maybe they have 10 domains to start out with, and the hope is eventually they'll get there with everything. But it's a long process. And you may line up an example like this for healthcare. You may have dozens of domains. Each domain may have dozens of products in there. And usually you look at your OLTP systems and that guides you, because your domain is going to be in charge of OLTP systems and the analytical data. So how can we break that out and not have overlap? And even things like, well, I can't break, if I've seen people say, well, our company buys other companies and we'll just, well, that's a great way for a data mesh. We'll just, each of those companies will be part of the mesh. No, it doesn't work that way. Because if you buy 10 companies, each of those companies have HR, you can't have 10 domains that each have an HR product. They have to be combined into one. So each of those companies you bought will have to reorganize into one domain for HR and one domain for finance on there. So and this gets more into it. So I can have this architecture where I have these domains like manufacturing, sales, and supplier. They're source aligned, meaning they really work well for the people inside that domain. Imagine if I'm in supplier domain and I build out my domain and make it available for others to pull metadata and data from it. But it may be confusing, some of the terminology you use, the way the tables are laid out, for people outside of supplier group to understand that. So what, and this is what Jamek put in her book, is then you create a consumer line to solve that problem. So you copy that data into a way that's more consumer friendly and then people will consume that data from there instead of from the source. You also can have problems with, especially performance-wise, the combining data from multiple domains. Manager and I need to create a P&L statement, and I need to pull data from sales and manufacturing, maybe dozens of other domains. I can't do that on the fly. So to solve for that, you copy that data into an aggregate domain, as she calls it, and then you pull from that aggregate domain. Now, the big problem I have with this is, well, you're all about decentralization, and now you're centralizing it. So now who owns the P&L aggregate domain? And now you're having additional copies of the data in there. So a real challenge with this, in my opinion, with trying to solve by creating additional domains and adding additional complexity on there. And then you look at it, you're like, well, how do you master data? Or how do you avoid having tons of duplication? I can't have all these domains all pulling data from, say, Salesforce, because that'll be crazy. What happens if I have to clean it? All the domains have to clean this data. So instead, what you can do, which is the exception really to what she talks about, is you can have a customer 360 where you pull the data, master it, clean it, and then the other domains pull from there. Now it gets complex though, because you're having all these arrows going everywhere. And this is a small example. You can have many sources, many domains pulling data from many other domains in there. So this is where it gets very challenging. And this is where you have a lot of concerns. And I think I have about 50 of them in my book. So I'm trying not to be somebody who's anti-data mesh, if that's a term. I'm trying to say data mesh can be great, but it's for a limited number of companies. And they have to be aware before they get into it of what these concerns are. And I've talked through some of these. I won't go into much more other than to point out a couple, like organizational change in there. Imagine going to each domain and say, hey, guess what? We're going to implement a data mesh. All that analytical, all that operational data you've been sending to us, IT, don't send us to anymore. You need to go and create the analytical data that we had done, but now you have to do it. And so you have to hire your own team, create your own infrastructure, and we may have principle 3 and 4. We may give you some tools to make it easier, but go for it. And they're going to go, well, look, I can barely keep my own stuff working. Now I got to do all this additional work. Why should I do it? What is your answer going to be? For the greater good? I don't know. This is where customers struggle. You have to get everybody to buy into this, because all it takes is one domain to say, I'm not doing it. You want the data, take it. Then what are you going to do? You have this exception to the data mesh. on there. And this is where, and what I'll talk about in a minute, you get a combination of centralization and the data mesh in there. But there's a lot of issues and concerns with a data mesh. Not to say you can't do it, but you have to be very aware. And even in Zamek in her book, she says, should you adopt data mesh, you have to score medium or higher on these categories. So when you look at things like long-term commitment, early adopter, tech at core, that right away, that's 99% of the companies are not that way. Modern engineering, I mean, I've got customers that are still using mainframes in there. They already have to have organizational complexity. And so really only I see most of the companies are more banks and finance companies that already have that organizational complexity. So at best, you're going to see a very small percentage of customers adopt a data mesh. You may see a good number take pieces of that, but it's just very challenging to build a data mesh in there. Data mesh on Azure. So this is actually pretty short because, again, data mesh is not about technology in there. So there's a thing called Cloud Scale Analytics. It's helping with Principle 3. You can use Cloud Scale Analytics for other architectures. So you can use it to build out a data lakehouse. The idea is to provide scripts that make it easier. And you'll see that they have things like landing zones in here. I won't go into this. This is the way Synapse does it. So it's just a shortcut process for building out domains. It maybe gets you 20% of the way there, I will say. Most customers will take that and build on top of it to satisfy their needs, because what happens if you're not using Synapse? What happens if you're in Amazon and Google? You got to find what they have, and it's very challenging in there. Now, there's within Microsoft Fabric, that new product, there is the concept of domains in there, and you can create domains and new type workspaces domains. But as I list here, it's partially solving domain ownership. It's really not helping much at all with data as a product or self-server infrastructure. Maybe in the future, it'll help with federational computational governance. So again, it's technology that's helping a little bit with the principles, but 90% of the principles of 90% of data mesh getting implemented is that cultural change. They also have the idea of fabric of one lake. So this is where all the data for anything you're doing in one lake in a tenant is going to be stored in workspaces, which are essentially just folders within one lake. And this allows you to have each of these domains, make it easier for them to land data in a centralized location, but it appears to be a virtual location where the data that appears to be centralized, but the data could actually be all over the place. So I could have in one lake this logical representation of all data that could be local in that lake, but also through shortcuts, I can create those shortcuts to data that could be all over the world on there. And so it's kind of like a virtualization layer on top of that. So, and this gets a big, sometimes the debate is, do I want to centralize all my data within a data mesh for reasons like security and performance, or do I want to go to a virtualization layer, but now the trade-off is performance in there on that? So I see a big mixture of way customers go with that. So on that, you have data mesh type 1 and 2 and 3. So, and this is the way I just broke this out. This is not dynamic stuff. So on the left-hand side, you think of mesh type 1 is all the domains are using the same technology. The data is all kept in one enterprise data lake, and each domain gets their own folder or container in there. That's kind of what the previous slide is about. So the idea is more centralization, less flexibility, but most customers are taking this approach, centralizing the data lake, because it's so challenging to have all these data lakes and then link them all together. And that's where we get into mesh type 2, where all the domains, again, are using the same technology, but each domain has their own storage. That's the same technology. So like data lake storage N2. So the challenge becomes, how do I connect all that? How do I create a report or query that's going to go and pull that data together? I can go to what Jamek suggested and create aggregate domains, but the aggregate domain's got to pull that data. So it's the same problem, just one step earlier. How do I pull that data together in there? Now, and so most customers are using type 1 and type 2. Maybe I would say 7% type 1, 30% type 2. Nobody's using type 3. which is the pure data mesh, which means any domain can use any technology they want. They can use any storage they want. Imagine having domains, one's using Google, one's using Amazon, one's using Azure. Even within Azure, one's using Fabric for the warehouse, one's using Synapse, one using SQL database on there. You forget about 3 and 4. How are you going to create scripts that are going to be used for all those technologies? How are you going to have rules that are going to work for, and security that's going to work for all different cloud providers, which are very different security in there? So nobody will ever do type 3. At least that's my opinion in there. It's going to be some type of variation as technology gets better, but you're always going to limit the technology that you can use. I think that's always going to be there. So in the end, you'll have, when I touched on this before, you could have customers that may start building out a data mesh, but they will have to centralize a lot of data, especially if they already have something exist. You can't just flip a switch and everything's a data mesh. So there'll be some rollout of maybe new domains coming in will be a data mesh, and I'll start rolling out other centralized solutions. And over time, maybe I get there where most are not centralized and part of the data mesh. Most of the customers I see, especially the ones that are highly touted out there, that they have a lot of videos where they talk about their data mesh. Most of them, you talk to them, and I've done this for my book. They're like, well, we have like 10 domains. We want to get to like 100, but it took us 2 years to get to 10. So it's going to be a long time. I haven't found any company that everything's a data mesh now, even if they are not a pure data mesh, even just partially. It takes forever on this, which is a big problem right there. If you can't go to a company and say it's going to take 2 years to build a data mesh, well, for 2 years, what are they going to do with the centralized solution? Are they going to pull resources off that and not update things in there? So it's a big challenge in there. But in the end, the data mesh concepts will help with a better way of thinking of how to get value out of data. And so that's where I recommend people read about data mesh. And at the end, if you go like, well, no way, we're not building data mesh. But you know what? I like that principle of domain ownership. So maybe we can utilize some of that, or even some of the governance or 3. Maybe we can do things to help other parts of our company automate things or build things out that could be part of the enterprise solution. So in the end, when to use, last slide, when to use what architecture. A modern data warehouse, people are still building it. If you have a small amount of data, maybe if you came on-prem and you're used to that and never used a data lake before, maybe you go to the cloud and you don't use a data lake. And that's fine, with the big caveat, are you going to need to ingest more data down the road? Are you certain that you're never going to have to expand on this, which 99% of the time is it's going to happen. So now you could be locked into this solution and you start incorporating more data and you're like, God, I really need a data lake on that. So really think through that. The data fabric, so it's really an evolution of modern data warehouse in there. So it's the same things I mentioned, except you could build out something that can handle these different data sizes. And so that data fabric, then the question is, that relational storage, do you need that? And this is where I see a lot of customers getting away from that, but they still have valid reasons why they need to have relational storage. I've even seen people say, well, we have a product that only works against relational storage, so I have to copy the data in there in order to use that product. It's like, okay, that's a great idea. That's a great reason for it. Data Lakehouse, I will say use it until you can. And if you come into an issue like, uh-oh, wait a minute, I forgot there's an application that needs relational storage. Okay, fine, just copy that piece of data into that relational storage for that application. Or we really need to get extra performance, we just can't do it in the data lake. Copy that piece of data into the data lake out into a relational storage in that case. And data mesh, again, very unlikely anyone in this call is ever going to build a pure data mesh. When I go to do presentations, the last one I gave a couple months ago, there was about 100 people in the room. How many people have heard of data mesh? So I would say, raise your hand. About 80% raised their hands. How many people have built a data mesh in production? Nobody raised their hands. Nobody's ever raised their hands in any of the times I've asked that question on there. So there again is the hype, but the reality is there. And now, yeah, I've seen some companies that have built a data mesh, but there are a lot of exceptions to data mesh in there, which is fine. But understand going in what exceptions you're going to need. And in the end, most customers are going to take pieces of these architectures and build their solution. Whatever you want to call it, I don't care. You can call it James's architecture if you want. Actually, that's not a bad idea. Maybe we should James's power architecture. There you go. And say I build it based on what I learned from him. All right, cool. So questions. I'm just going to go backwards. Leon said, for us, the good thing about data mesh is it can be incremental. Yes. Central platform is first, and units can onboard at their own pace. Raise his hand slowly. So that's great. So that's kind of what I say, and that's where really all customers are going at this approach. I haven't seen any, because data mesh is really hard to build for a new company. Even Jamek just says you shouldn't do it for a new company. So they're going to have some centralized approach going in. Data mesh versus data mart. So a data mart is generally a subset of a data warehouse or a data lakehouse, and you're putting it in a format. And this is what my blog was somewhat about, is you put in the format that other people can use. That makes it easier for them. In that, this goes back to like the Kimmel Inman days conversations, is the data warehouse may be too much for them. They want it into a smaller unit, and maybe they even supplement it with other data, and it becomes a data mart. So instead of having a data warehouse with all the subjects, you have data marts that have one subject. Now, that you can think of that as a high level. Now, within products like Microsoft Fabric or Power BI, you can create your own data marts, which could be, I'm in the department, we need to do our own thing with the data. Let's pull it in, create our own data mart, and use that. And it's not for anybody else outside of our department to use. So it's really, if you think of a data mesh versus a data mart, data mesh, again, is a culture change in there. The data mart could be within domains. They have their own data marts in there. And that's how I kind of would relate it. But as you say, it's technology data mart where data mesh is the concept. Another one, if we buy patient claims data from external providers, we would have 3 different ownerships: provider, consumer, and analytical applications. It seems the domain definition goes hand in hand with the ownership and not the data itself. Yeah, and that's yeah, I would say that's true. Who owns the data is a way to look at who owns the applications, and this is where you get into the domain, the 3 Ds, domain, and I forget it sometimes. I'll go back to it. The domain, a lot of these acronyms that they use. Domain-driven design is how are we going to do that? And there's no standard definition of there. People have different interpretations. Do I break it out by business capability, business purpose? I've seen people try to do it by organization, which I don't think is the right way to go. Again, each organization have their own departments that are overlapping, like HR on there. Do we go by where we get the source of the data from? A domain could be simply grabbing data from some third party, and that's it. They're not doing anything with that data. For OLT people wise, they're just grabbing that data and then creating analytics out of it in there. So it's a great question that doesn't have a great answer to it. And feel free to raise your hand if you want to come off mute. In there, we got 5 minutes to go. One of them in here, I think it's more of a comment too. We have individual domains that work well. Main challenge is cross-domain mapping. Without it, you have lots of individual analytics that might work well, be efficient, etc. But you need the ability to cross-query domains if you want insights into org. So that is the big problem I have when I first read the book that she had. It's like, well, you act like, and that's where when you get into the idea of code, the other code a lot of times doesn't really care about other code. But in the data world, that's very relevant. You have to have code, you have to have data joining other data in there. So how are you going to do all this? And that's where you get into aggregate domains. And I was like, well, okay, now you're centralizing data in there. And I can't build a solution. A lot of the book is theory and automate stuff, and it should work fine. Hopefully will work fine with future technology. But the challenge of pulling data and data lakes that could be all over the world, that got to be combined, is even virtualization software only goes so far. It's really challenging. That's a big challenge with data mesh in there. And that's where people have gone an approach of centralizing the data and keeping it close because of the performance issues. And also I'll add another challenge I have with data mesh is that each domain is thinking of the way they want data laid out for themselves. They don't care about other domains. Well, now you have people outside of those domains that want an enterprise view of all the data. And she'll kind of argue that you shouldn't do that. But I argue, I've been doing this for almost 40 years. People are going to want an enterprise view of all that data. And if you have each domain going and building out that domain and not thinking of the enterprise solution, somebody's not going to do the work of pulling all that data together and there. And yeah, you have Principle 4 and they should be following things, but they're not going to care in a lot of aspects of how this is going to join up with other data. So now all that complexity, which was taken care of by the centralized location on IT before data mesh came around. Now, how is somebody going to solve all that? Just little things like, hey, they use different reference tables in each of those domains. Oh no, now we got to go and clean all this data using a common reference table. How are we going to master all this data? All that stuff was kind of glossed over and not really impressed upon. And I think that's a big problem with data mesh. Right. Anybody else? I can go on the questions.
I have one if you have time.
Go for it.
Yep. What are the common pitfalls you see, like mistakes company make, like when they implement Data Lakehouse? How can they avoid those?
Go to your friendly Microsoft person and have a discussion, or a consulting company or some other experts, or watch these videos and understand what the architecture is. I've had a lot of companies come to me and we want to build a data mesh. Okay. You don't really know what a data mesh is? I think so. Okay. Let me go through this presentation I just went through. And at the end of it, they're like, oh, yeah, we don't want to build data mesh. That's not what I thought it was. Even the same with the Lakehouse. And again, this is my interpretation of Data Lakehouse, but it's without the relational storage in there. But they don't know of the trade-offs of not having relational storage. They never thought through that. And so the mistakes they made is they just jump into it, especially if they hear latest buzzwords, oh, mesh, we're going to go build the data mesh. And then 6 months into it, they're like, oh, I didn't realize this is what it actually was, or I didn't think through these concerns. So go through the concerns, and then at least you'll know, and then you can take action up front to go and work through those concerns in there. So I would say the biggest thing I see when customers actually build a data lakehouse is a lot of times the governance piece, which I didn't talk much about here, but their data lake becomes a data swamp because it's not just using a product, like Microsoft product called Purview and Calibra, and there's a lot of them, and they're great products, but you have to be trained to use them. I don't want to go and, oh, this tool, Microsoft Fabric, is great. I can just pull in data from Salesforce and I'm going to transform it and I'm going to write it into a data lake and then I'm going to build reports off that. And they go and they do that. And then somebody goes, well, somebody already did all that. Why'd you do it again? They go, I don't know. Well, nobody trained them to go look through a product like Purview to see if somebody's already built it. So governance becomes the biggest part that people skimp over. And it's not just implementing a product and saying, hey, it's there, go and use it. It's going through best practices and telling people to go and look through the product, use the product to see what's already been created so we're not overlap and creating duplication of effort. And then that gets into standards of securing the data, making sure only people can see it who they can, understanding how all the technology works so people are not dumping sensitive material into a folder that's not protected properly, and now you're on the front page of the Wall Street Journal.
Sounds great. So anybody have any more questions, or we just start wrapping up?
Yeah, so feel free to send me out emails afterwards if you have any questions. Like I said, I'll send out these slides. There's my email. Happy to have email conversations. Sometimes I even jump on the phone with people. I love talking about this. I can talk about it all day. I have been, and I already started to lose my voice, but this is a lot of fun stuff. And I'm not always right, so I like to hear other people's opinions on this. My book is my interpretation of these things. And I wish there was a main source you can go to, but there is not. And so I just take in whatever everybody else does, what my customers are doing. People come to me with some awesome ideas. I'm like, that's great. I'm going to put that in the book. So that's why I'm happy to have those conversations.
Cool. But that was very engaging and knowledge-packed session on data architecture, to be honest. And huge thanks to you for sharing your valuable insights with us today. And thanks everybody for joining us today and making this event really good. At the last, I just want to say that save the date for our next session. It's going to be on 30th August with Pavel on One Lake, which is the foundation of Microsoft Fabric. And in meantime, feel free to connect. And looking forward for the next session. Thank you.
Thanks, everyone.